Everyone, we have all of these ones on top. So 1 doesn't change. 1 isn't changing. I'm just looking at the denominator. I'm just completely looking at the denominator. So if I eliminate my numerator, since they're all 1s, I can just look at my denominator, which happens to go 2, -6, 10, -14. So if I just focus on my denominator, I'm going to notice it goes 2, 6, 10, and 14. And I'm just going to look at the positive versions of them. Because to get from 2 to 6, I add 4. Then I add 4. Then I add 4, so it is arithmetic. And if it's arithmetic, I don't care about the negative and positive, because as soon as I realize it's arithmetic, I'm going to say, well, I'm going to account for that positive and negatives by doing -1 to what power? Would I use n or n minus 1 in this one? Yeah.
You would use n minus 1 because it starts positive.
Yep, absolutely. It starts positive, so I'm going to use the n minus 1. And it's not something you have to memorize. You can just say my first term would be 1 minus 1, which is 0, which would make this positive. All right, so this takes care of the positive and negatives. So I'm just looking at our difference is 4, so it's arithmetic. It is arithmetic. Our difference, our common difference is going to be 4. So we can go right into writing our explicit formula. And explicit formula of our arithmetic sequence is going to be our difference times n plus c, where c is, can someone tell me what that c is? I forgot already. It's been so long. How do I find that c value? Mike?
It's like A1 plus something.
Not plus. Minus? Yeah. Minus d. Yep. It's a sub 1, our first term, minus our d. So in this example, our d is 4, so we have 4n. Plus, we have our first term is 2, minus 4, which is minus 2. Does this account for my entire sequence, though? No, it doesn't, because what do I have to have on top? I need a 1 on top, but I really need... So we could think of it, this is my denominator, right? So my actual 1 is going to be 1 over 4n minus 2, but I need to account for that positive and negative. So my end answer should be -1 to the n minus 1 would be my final answer. Alright, so it's really easy when you focus on the denominator to just give your answer to the denominator. I'd only take off like half a point if you did that, but just make sure you include all the parts. You include that 1 on top, and you make sure you include your positive and negative if need be. Alright, so if I have a positive and negative, if it's arithmetic, I just use my -1 to some power. If it's geometric, I just multiply by a negative number. Alright, who's got questions on the homework? Or I should say, what questions do we have on the homework? Where are we? Where are we? We are 1. Mike? 49? 49. Find the formula for the nth term of a geometric sequence with our third term is -12 and the sixth term is 96. Alright, find the formula of the nth term of a geometric sequence with a third term is -12. Let's just go. A sub 1 equals a sub 2 equals a sub 3 equals a -12. A sub 4 equals a sub 5 equals, and a sub 6 equals a 96. So what can we do on this one? We know it's geometric, right? So we're looking at multiplication. What could we do? Yeah.
Find the common difference.
We find the common difference. And how would I do that?
Well, I just kind of guessed and checked.
You guessed and checked. And what did you guess and check to?
-2.
-2. Does -2 work? All right, what else could we do? Yeah.
Didn't you do the, what's it, explicit formula?
Yeah, we could do an explicit formula.
And like plug in the A6 and A sub 3.
Mm-hmm. Yep, that's it. So we could do an explicit formula. I don't know how the book does it, but what I usually do is I kind of pretend this is my first term. All right, so I relegate this to just, hey, I don't know my first term. I could definitely guess and check, but I'll make this as my new thing. Or this is A sub 1, and this is A sub 6, just to find our common ratio. Okay, so not A sub 6. That would be A sub 2, 3, 4. So this is my A sub 4. If I reverted to just this. All right, just to find our common difference. Just to find our common difference. So that means we just come up with a common or an explicit formula, which is A sub n equals our first term times r to the n minus 1. Well, I'm going to say this is my A sub 4 for a second, so that'd be 96. Equals that first term, which is negative 12. Times my r to the, and in this case it'd be 4 minus 1, which would be 3. All right, so we divide both sides by negative 12, which you'd come up with as a negative 8. Equals r cubed. You take the cube root of both sides, and you'd see that r, in fact, equals a negative 2. And now we have r. We can use that to get our first term, right? And we can go from there. Who asked the question? Mike, does that make sense? All right.
Okay, so would the first term be negative 3?
The first term would be, yes. Mm-hmm. Or, like Alex did, just guess and check, right? At the end of the day, you can always guess and check. But it's always nice to write down the explicit formula, because then if you're wrong, at least I can see you're going down the right path. All right, other questions? Yeah. 41? 41, we're supposed to find the first 4 terms, and then we're supposed to do this sequence. So my very first term is 3. Then my second term is going to be, well, let's go ahead and read this in English. This says the term I want equals negative 3 times the term before it, right? Does that make sense? Okay, so my next term is just going to be negative 3 times the term before it, which is going to be a negative 27. No, I'm on the next one. It's going to be negative 9. My third term is going to be negative 3 times the term before that, which is 9, which is going to equal, which times negative 9, which equals a positive 27. Well, if you just notice, we're always multiplying by a negative 3, right? So I'm just going to go ahead and check really quick. Well, this is just times negative 3. This one is just times a negative 3. So my next one is also going to be times a negative 3. So it must be geometric. Is that good? Okay. Other questions? Alex?
Well, in 41, what does it mean, like, n is greater than or equal to 2?
They're saying you have to, so they give me c sub 1, right? So they're saying your next n value has to be 2.
Oh.
That you can't go back. You can't go to c sub 0. So that's all it's saying is I would plug a 2 in for next one. But that's what we traditionally do. So we kind of stayed away from that notation a little bit, just because we had such a short time to go through this stuff. Is that kind of what threw you off too, Sophia? That n is greater than or equal to 2? Yeah, don't worry about that. That's all it's saying is, what's the next term, right? All right, other questions from the homework? No? Okay, then we'll get into today's lesson, which is continuing on geometric. But now we're going to talk about the sums of geometric series. All right, and we're just going to start with the formula. So just like with arithmetic sequences, we can find the sum of a finite geometric series. And it has a formula that looks like this. It is going to be a fraction. And on top, we're going to have a sub 1 times 1 minus r to the n. And on the bottom, we're just going to have 1 minus r. Note that this only applies to a finite series. A finite series where r cannot equal 1. Because if r equaled 1, it wouldn't actually be, every number would be multiplied by 1, so it wouldn't actually be a geometric sequence. It would just be negative 3, negative 3, negative 3, negative 3, negative 3. So that's the only reason why r cannot be 1. Alright, so we're going to find the sum of each of these geometric series. So it already starts off saying that it is a geometric series, so we should be able to agree with that. Well, there's three things we need to put in the formula. I need to know my first term, I need to know my common ratio, and I need to know that n, which is the number of terms that I'm going to have. Well, if we look at that first thing, I have my first term is 1. I have my common ratio, well, I'm going to multiply by 1/3 for each of those, so my common ratio is 1/3. I'm going to write this down in a second. But we don't know how many terms there are. We don't know how many terms there are. So like I said, I'm going to write down what I know. I know that my first term equals, I got away from me while I was walking. My first term is going to equal to 1. My common ratio is going to equal 1/3 because I multiply by 1/3, multiply by 1/3, multiply by 1/3. Maybe I'll write that down. So this is times 1/3. This is times 1/3. But I don't know what my n equals. I don't know. So we're going to go ahead and find that end. So the first thing we're going to do is we're going to find n. And in order to find,
Divide 243 by 3.
Not quite, because that can come out the right answer. But we're going to do something like that. This can be similar to that. Because if you take 243 divided by 3, what do you come up with? 81. I could tell you, because we're basically multiplying our denominator by 3. There's no way I can multiply it by 3 that many. Yeah, that'd be a much bigger number. So we could honestly say, my next term is 9 times 3 times 3 times 3. And at the end of the day, if I'm on a test and that's all you can do to get the number of terms, then by all means do it. All right. The easier way is to come up with an explicit formula. Come up with our explicit formula. And the explicit formula for a geometric sequence is going to be a sub n equals my first term times my common ratio to the n minus 1. Well, the term I'm looking for is 1/243 because that's my end point. So we're just going to plug in 1/243 in for that a sub n. And that's going to equal 1/3 to the n minus 1. Up until now, we only have one strategy. I'm going to show you how to use your calculator the next time we have to do this. But just for now, just for practice, I want to rewrite this as 1/3 to some power. And all I'm asking myself is 3 to what power equals 243? And if you need to guess and check on that, it's fine. Just do 3 times 3 times 3 times 3 times 3 and see how many times you have to do that before you come up with 243. And what power is that? 3 to what power gives me 243? Jack? 3 to the 5th. Nice throat clear first. It's good emphasis then. So it's 1/3 to the 5th equals, or 1/3 to the n minus 1. Well, that tells me that these bases are the same, so I can just say 5 equals n minus 3. So my n must equal 6. I said we only need 3 things for the formula. We need our first term, our ratio, and our number of terms. So all we have to do is plug that information in. So I'll put a little wall here saying now I'm actually doing the work. So our sum of those 6 terms is going to equal my first term, which is 1, times 1 minus our r, which is 1/3, or 1/3, to the n minus 1, where n is 6, so it'll be 6 minus 1. Ooh, scratch that. It's just to the 6th. It's not minus 1. All over 1 minus our r, which is 1/3. Decimal answers are 100% acceptable. I went back and forth. I just put this as a fraction as 364/243. But by all means, just put it as a decimal. All right? I'm not expecting you to simplify fractions and stuff. Okay, so our next one, it is an exponential function because we have a number to some variable, so it has to be geometric. Remember that. If it's exponential, it has to be geometric. So that means I need a first term, I need the common ratio, and I need the number of terms. The reason why I picked this one out is because my first term here was a sub 1. Is my first term on this one a sub 1 as well? Jack, you're shaking your head no. What should it be? It should be a sub 0. So there are times where your first term is not a sub 1. And this is one of those cases. A sub 0 is actually my first term. And that comes from the fact that we start at 0 this time instead of 1. Well, a sub 0 is just going to be 100 times 1.05 to the 0th power. Anything to the 0th power is 1. So this, in fact, just equals 100. My common ratio, well, that's just the base of our exponential function. So it's going to be that 1.05. So this is, in fact, 1.05. Well, I know how to find my n. I just look at that top number, right? I just say it's 10 and I move on. Says the guy that's stalling for someone to say, no, that's completely incorrect on this.
No, that's completely incorrect.
Well, thank you, guys. What should it be instead of 10? What should be instead of 10? Rosie, do you know what it should be instead of 10? It should be 11, yeah. I guess we would put a question mark after it. The Rosie answer, 11? Yes, it is in fact 11, and that's because we are now starting at 0. So if it was 1 through 10, I would have 10 terms. But we started even lower. And if you need to, if you have to on the test, go, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 terms. By all means, do it. Count on your fingers. All right, so we have 11 terms. I got all the information I need. We're going to go ahead and plug all that stuff in. So we're looking S sub 11 equals my very first term, which is 100. We're going to multiply that by 1 minus our R value, 1.05, to the nth power, which is 11, all over our 1 minus our R value, which is 1.05, which if we plugged in our calculator, this one I did put as a decimal, just to show you that either way is acceptable for me. I came up with 1420.7. Okay, someone real quick, because we're talking about finite sequence. How do I know something's a finite sequence? Chris?
There's an end.
There's an end. And if we have summation formula, there's a number on top, not infinity. And if I give you something like this, it's dot, 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 and I don't have dot, dot, dot after. So this is what we need to look for to do these finite sums. However, remember when we worked with the arithmetic sequences? We could only do partial sums. It had to be finite. The problem with geometric sequences is we can actually calculate some infinite sequences or series. We can do some of them. We can't do all of them, but we can do some of them, and it is predicated by our knowledge of our common ratio. So one of these we can do the sum of, and one of these we cannot. Now if I'm adding all these together, does someone just want to come up with a guess at which one we can actually find the sum of and which one we can't? Just picture adding all of those together. Someone just might make a guess. You can be wrong. Jack?
Can we do the one on the right?
We can do the one on the right, and we cannot do the one on the left. And why we can't do the one on the left, let's talk about that. Well, I have 1, 3, 9, 27. I'm multiplying by 3. So that dot, dot, dot tells me we're going to just keep bigger and bigger, right? Our numbers are going to keep getting bigger and bigger. And even if I graphed this, just a fake graph, not anything too specific. Maybe I start at 1, 3, 27. It's exponential, so it goes up bigger and bigger and bigger. So I keep adding a bigger and bigger number onto it, which means eventually I'm going to reach infinity, and I can't calculate infinity. This is called divergent. And not the movie, just the graph and the sequence. It is divergent. It is divergent, and if it's divergent, cannot find the sum. You cannot find the sum. Cannot find the infinite sum. And that's all you're going to put on the test. If I give you an infinite sequence and it turns out that your R is bigger than 1, absolute value, you're just going to put cannot find the sum. Like Jack said, we can actually find this sum. If our common ratio, the absolute value of it, is less than 1, we can actually find the sum. And that's because these numbers are going to get smaller and smaller. They're going to get closer and closer to 0. These are smaller and smaller. So the graph of like this would look something like this. It's just going to converge on 0. And this is called convergent. And we could find the sum. In fact, we have a formula to find the sum. And our formula for our sum is just going to be our first term all over 1 minus our common ratio. So in fact, it's even easier formula than with our finite sequences. And the next page I kind of have a cheat sheet. Kind of a cheat sheet at the very top. It is, what if Mr. Pavement gives me a finite sequence? I use that left one. If I give you an infinite sequence, you use that right one. However, you must check your R value. And that's what's down here. If R is less than 1, it's an infinite sum, so we can actually calculate it. If your R is greater than 1, then we do not have an infinite sum. So R is less than 1 is what we're looking for to see if we can do an infinite sum or not. All right, so there's your little cheat sheet of basic. All right, so those are our two things. We're not going to start with actually calculating the sum. We're going to put things in summation notation first. And in fact, I picked these on purpose because we're going to use our calculator. Because to put a number in summation notation, I need to know where we start and where we end, so I need to know this term. So we're going to start off by saying what we do know. I know my first term is 5. I know it's geometric, right? This is definitely geometric. So it means it has a common ratio. And what's my common ratio? If I go from 5, 15, 45. Mike? 3. Thought you raised your hand for a second, and it looked like you were just... All right. I don't know what my n is. My n's a mystery, so I'm going to use this information to come up with an explicit formula, which is a sub n equals my first term times my ratio to the n minus 1. Now before, what I would do is I'd plug this in and solve it, which is maybe okay for this one. It might be okay for this one, but I'm going to give you some hard ones that you don't want to have to do that. So at which point, you're just going to pull out your calculator. And your calculator is going to tell you what that n value is. So we're going to bring out our calculator. Let's hope my calculator's still up. And we're just going to go into our y equals. Just remember, we were in parametric stuff, so you might have r equals. Make sure you go to mode. Right? Make sure you go to mode and make sure your function is highlighted. All right, then we're just going to be in our y equals. Now I don't have n, so we're just going to use x in its place. And so all we're going to do is we're going to type in, what do we have, 5 times 3 to the n minus 1? Yep. We're going to do 5 times 3. And anytime I'm raising to a power other than just one digit, I'm going to put it in parentheses. So I'm going to do x minus 1. All right, so this is now 5 times 3 to the x minus 1, or n minus 1. Or we could graph it and try to eyeball it, but the easier thing to do is you look right above your graph button, you have a table button. You have a handy table button. So go ahead and hit second and go to your table. And let me know, is anyone having problems typing this stuff in? Is it not working?
It just said undefined variable, but then I clicked escape and now it went away.
Oh, that's because we're still in the
We're still in the wrong mode.
we're still in parametric mode.
So, well, how do I get out of parametric?
Right there it says polar. We're gonna go to polar. We're gonna go to function.
Oh, okay. All right.
There you go.
Oh, there it is.
All right. If we notice, our 1 is by 5. Our first term is 5, right? Our second term is 15. Our third term is 45. That means our fourth term is 135. Fifth is 407. Our seventh term is 3645. So without doing any heavy lifting, our seventh term is at 3645. Did everyone's calculators work on that?
Yep.
So we just find the number we're looking for, and this will tell us what term number it is. So our n is just 7. So we just come back here and we say, well, our n equals 7. So we used our calculator. Maybe if you want to put notes on there, around there somewhere. So I use calculator. I use the calculator. And we came up with n equals 7. Now we can do our summation notation, which is we go from 1 to 7, and we just put our explicit formula, which is 5 times 3 to the n minus 1, and that is our summation formula. So anytime we're missing our n value, we can use our calculator to find it for us. In fact, our next one is also geometric. This guy's geometric as well. Our first term equals 48. Can someone tell me what my common ratio is for this one? Yeah, Ethan.
-1/2.
It's -1/2. I can't find my n yet, so we're going to come up with an explicit formula. Remember, we don't need to, if I know my n value, we can just jump right to our summation, but I don't know my n value. So we're going to go ahead and plug in our 48 for our first term. We're going to multiply that by our common ratio, which is -1/2, and it's going to be to the n minus 1 as well. Once again, I don't know my n, so we're going to go ahead and plug this in our calculator as well. This is a good one to practice on because you do have to use parentheses all around your -1/2. So you're going to have parentheses around your -1/2, and you're going to have parentheses around your n minus 1. So I'll kind of type it in. Try to do it on your own too. So I have 48 times, in parentheses, the negative 1/2 to the, in parentheses, x minus 1. And then you're going to go to your table, and you're just going to double check that your first couple terms are correct. Well, mine are, because it says 148, 2 negative 224, 312, 4, uh-oh. We have decimals, and I need to find a fraction. We might have to exit and actually figure out what we're looking for. 3 over 16. So we actually have to figure out what 3 over 16 equals. And 3 over 16 equals 0.1875. And so we'd be our 9th term. You good, Louis? Yeah. Okay. We're just rubbing in his face that he doesn't have a calculator. All right, so that actually is our 9th term. Using our calculator, we came up with n equals 9. So then we go right to our geometric sum, which is n. We don't use n. Let's use j equals 1 all the way to 9. Our explicit formula is 48 to the negative 1/2 to the n minus 1. All right, any questions on using our calculator to find our n value? It's a little quicker, isn't it, than having to set up an equation and solving for it? Let your calculator, you can use your calculator in all your tests, so might as well get use out of using them. Use out of using them? That seems like a great sentence to say. Make sure you use them. All right, our next ones are finding the sum. I'm going to tell you right now they're all geometric. They're all geometric. So we're going to check for 2 things. If it's finite, we can find the sum. If it's infinite, we can find the sum as long as our absolute value of r is less than 1. So we're going to make sure we know all that. So we know they're all geometric, because I told you that. And in fact, we can tell they're all geometric because all of these are exponential. And this one we can just eyeball and say, well, it looks like we're dividing by 2, so it must be multiplying by 1/2. All right, so they're all geometric, so we're good there. A is infinite. It's infinite, so I need to find my r value. Well, my r value is 1/2 times 1/2 times 1/2. So if it's infinite, I need to check to make sure the absolute value is less than 1, which it is, so we're good to find the sum. We are good to find the sum because our r value is less than 1. All right, so we're going to jump right to finding our sum. So I'm going to put the sum of, well, I don't know what n is. I'm just going to say it's infinite. The sum all together equal our first term divided by 1 minus our r value. So it is our first term minus our r value of 1/2. Well, that's just going to equal 16. So in fact, if we keep having this, and if we can reach infinity, which we can summate here, it actually equals 16 if we add everything together. All right, the next one, we're going 1 through 7. So that is finite, so I can find the sum. That's all I need to know is it's finite. I can find the sum whether it's geometric or if it's arithmetic. Either way, if it's finite, I can find the sum. Well, to find the sum if it's finite, we're going to have a sub n, not a sub n, s sub 7 is going to equal my first term times 1 minus our r to the n, all over 1 minus r. So let's go ahead and plug that information in. I need to find my a sub 1, so let's go ahead and do that. A sub 1 equals 2 to the 1 minus 1, which equals 1, so we got that. I have 1 minus my r value is always the base of my exponential function. So it's going to be that 2. That 2 right there. So this is my r value right here. It's that 2. So that's going to be 2 to my n, which I said was 7, because we go from 1 to 7. That's how many term numbers we have. And we're going to put that over 1 minus r, which is 1 minus 2. And this whole thing's going to come out to 127. One last time for the fun of it. Is 7 always going to be our n if 7's up here? No, we have to look at this number, right? If this was 0, it would have been 8. If this was -1, it would have been 9. So we have to count. This just says there's 7 terms between 1 and 7. That's where that 7 comes from. You have to look at that 1 to make sure it actually is 7. All right, continuing on. These are both geometric on the bottom because they're both exponentials. And they're both infinite. Both of these are infinite. This guy's infinite as well, and they're both geometric, infinite. Which means I need to check the r values. Just remember, r value is that guy that's the base of our exponential. So the r value on the left one is -0.99. So I'm going to say absolute value of -0.99. Well, that is definitely less than 1. Well, barely, but it is. So we're okay to find the sum. Our other one, though, is 1.01, which is greater than 1, which means it is divergent. And we can't find the sum. Can't find our infinite sum. All right, so we're done with that one. Now we just have to do this one, and we are done. All right, it's infinite. In order to find the infinite, I need to know my first term. Well, we do start at 1, so it's a sub 1 equals 100 times -0.99 to the first. So I replace the 1 with the j. Well, that's just 99% of 100, so it's -99 is my first term. My r equals a -0.99. And it's an infinite sequence, so we're going to say s sub infinity equals my first term all over 1 minus r. Well, my r is a -0.99, so it's actually going to be minus a -0.99. I put this one in a fraction, but like I said, a decimal would be fine. I put it as 9,900 over 199. But a decimal would be 100% suffice there.